Welcome to this explainer. Look, if you've ever felt that massive spike of anxiety when you're sending crypto out into the void of the blockchain, just praying you didn't mistype a single random digit, well, you are absolutely in the right place. Today, we're taking complex blockchain code and transforming it into simple, structured on-chain identities. We're going to map out the exact architecture of the Ethereum Name Service, or ENS, and see exactly how it functions as this massive global identity namespace.
This right here perfectly illustrates the immediate problem that ENS actually solves. Take a look at a standard Ethereum wallet address. It is a terrifying 42-character hexadecimal string. I mean, it's literally impossible to remember, and one single typo, poof, your funds are gone forever. No way to get them back. But now compare that to just alice.eth. It's clean, it's totally human-readable, and it just works. Basically, ENS takes that chaotic string of machine data and seamlessly maps it to a human word we can actually understand. So here's our roadmap for today. We're going to cover 1. Fixing the blockchain address. 2. The registry and resolver model. 3. Decoding the namehash algorithm. 4. ENS v2 and hierarchical registries. And finally, 5. A global identity namespace. Let's dive right in.
All right, Section 1. Fixing the blockchain address and really making Web3 user-friendly.
So this whole journey actually goes all the way back to the original 2017 vision of ENS. The goal was straightforward, but honestly, absolutely massive in scope. Make blockchain transactions user-friendly and just totally eliminate the chance of catastrophic human error when we're interacting with the decentralized web. But what's really fascinating here is what an ENS name actually is under the hood. It doesn't just swap complex hex strings for text like a simple nickname. Actually, every single ENS domain is an ERC-721 NFT. That means it is a fully user-owned, tradable asset. You're not just renting space on some giant tech company's server somewhere, you literally hold the cryptographic keys to this name. And because it's an NFT, it acts as this highly portable Web3 identity, kind of like a digital passport that just travels with you everywhere across decentralized apps.
Moving on to Section 2, the registry and resolver model, or how we actually map names to data.
Okay, so ENS is basically split into two main pieces. The first one is the registry. This is the core smart contract ledger that stores all the domain ownership info. Think of it like a giant central database, or maybe the spine of a massive phone book. Now, it doesn't hold your actual data, it just definitively tracks who owns a specific name, it manages when that name expires, and, this is crucial, it points queries directly to the second component, which is the resolver.
Which brings us to the resolver. This is the smart contract that does the actual heavy lifting. It's basically the translator. When someone looks up your name, the registry says, hey, go talk to this specific resolver. And then the resolver runs out and fetches the actual machine data linked to your name. That could be returning your Ethereum address so you can get paid, or fetching your avatar profile picture, or even loading up a fully decentralized website hosted on IPFS. But wait, this brings up a genuinely fascinating problem. How does a blockchain actually read a word like Alice? Because, blockchains are notoriously inefficient at storing and processing long strings of text. They speak in math and cryptography, right? Not in English letters. So how do we bridge that gap securely?
That brings us to Section 3, decoding the namehash algorithm. Let's translate some text to hash.
Let's walk through this process and break down the abstract cryptography into something a bit more concrete. To process a domain like alice.eth, ENS doesn't just store the plain text. First, it splits the domain into what we call labels, in this case, Alice and ETH. Second, it hashes those individual labels using the Kekeck 256 cryptographic algorithm. And finally, it recursively hashes them together to create a fixed 32-byte node ID. That unique 32-byte hash, that is exactly what the blockchain actually reads, stores, and understands.
And here's that actual recursive formula at work. It's pretty brilliant. The subdomain's hash is securely derived directly from its parent's hash. So you take the hash of the parent, which we call the remainder, and you hash it together with the hash of the specific label. This mathematical logic strictly preserves the entire hierarchy of the namespace. It means that the owner of a parent domain can completely control the resolution of any subdomains entirely on-chain. No centralized register are needed whatsoever. It's just pure, decentralized logic at its best.
All right, Section 4, ENS v2 and hierarchical registries. Let's talk about scalable architecture.
Comparing these two versions side by side reveals a massive shift. So, ENS v1 used a single, flat registry contract. And, it was really elegant in its simplicity, but it definitely limited flexibility. ENS v2, on the other hand, introduces hierarchical subregistries. That means every single name can define its own unique registry and rules. And let's look at expiration. In v1, if a parent name expired, its subnames could theoretically just stay active out there, creating these really weird, confusing zombie records. In v2, expiration is immediate. If a name expires, the entire subtree instantly vanishes. Plus, control has completely shifted from this rigid, owner-only model to a highly granular system that uses 32 specific roles.
So what do these new hierarchical registries actually unlock for us? Well, for massive organizations, or DAOs, it is a total game changer for instant subtree management. You can now reset hundreds of membership subnames all at once just by deploying a fresh registry, instead of paying those crazy massive transaction fees to revoke them one by one. It allows for shared registry architectures, it completely wipes out those zombie records we just talked about, and it introduces resolver aliasing. That basically means a company can maintain perfect brand consistency across multiple domains by pointing them all to one single shared resolver record. You literally update it once, and boom, it updates everywhere.
Now, you might be sitting there wondering, okay, but what happens to the millions of names that are already registered on version 1? Well, don't worry, there's complete backward compatibility. Legacy names seamlessly resolve via the ENS v1 fallback resolver. The system uses this incredibly clever universal resolver contract that hides all of this new hierarchical complexity right behind the scenes. So your existing .eth names absolutely won't break, and developers don't even need to rewrite their app code to keep reading them.
And our final stop, Section 5, a Global Identity Namespace. Thinking about this as public infrastructure. Because when you zoom out, ENS provides incredibly broad capabilities. For starters, it offers multi-chain resolution. That means one single name can hold you Bitcoin, Solana, and Ethereum addresses all at the exact same time. It's also serving as the absolute backbone for decentralized website hosting via IPFS, which makes those websites highly resistant to censorship. It acts as a universal login across thousands of different decentralized apps. And crucially, it features DNSSEC integration with traditional internet domains. And that right there highlights the core philosophy of ENS. You can actually import your traditional .com or .org directly into ENS to use on-chain. See, ENS isn't trying to invent parallel, fragmented, competing extensions that are just going to break the internet. It doesn't want to compete with a legacy web, it wants to extend it. It integrates directly with ICANN's existing DNS root, one namespace, absolutely no ambiguity.
Which brings us to this really powerful thought from our sources to conclude today's explainer. Quote, "The internet still needs names. The biggest shift today is who needs them now." End quote. We are moving so rapidly from individuals just needing a cool nickname for their crypto wallet to massive institutions, governments, and complex DAOs needing verifiable on-chain public infrastructure. So I'll leave you with this. If your entire digital reputation, your diverse assets, and your organizational permissions were tied to a single, highly secure, uncensorable namespace, how would that fundamentally change the way you interact with the digital world tomorrow?